Okay, let's get started. So our first exam is next Thursday. So a week from yesterday. It's the same procedure that you had for the pre-test. You're going to go down with your sun card. You can bring a graphing calculator, that's fine. And you'll go in there between 10:30 a.m. and 6:30 p.m. Thursday. You can work after 6:30. They collect all the tests at 8:15 p.m. So you can stay there and work as long as you want on it. So begin thinking about what time that day you're going to go. As a supplement to your studying, so this should not be all of your studying, but as a supplement to your studying, I'm going to set up a very long list of problems, and it's going to be like kind of optional and can earn you a little bit of bonus on the test itself. So it gives you a little motivation, but it should not be the entirety of your studying. Your studying, you should go back and rework homework problems. Go back to your workbook, find all those problems that I picked for class that you worked on. Find similar problems in the workbook. That's going to be the heart of your studying. This is kind of a supplement because this system of problems was not, designed with this in mind. Okay, I mean we know that this is different, right? This is different. So I've just picked the best problems that kind of match this the closest. So it's like kind of using this in the best way we can to match some of the ideas here. Okay? Like I said, it's not. I highly encourage you to do it. You can earn some extra credit on your first exam. Okay? But it won't hurt if you just ignore it and you just study everything in the homework and the workbook. It won't penalize you. Okay?
So it's from everything we learned.
It'll cover everything we've learned and will be for this first exam. Again, don't depend on these practice problems, these online practice problems, as the entirety of your studying. It's just the best problems I could find from this system to help us with that. So what I'm going to do is I'm going to set it all up this weekend, and when it's ready, I'll send out an email with information, but this is the website you'll go to, webwork.asu.edu. And then when you get here, it'll look like this. And then you're looking for Math 170, and you'll click on Ashbrook. And then, if you're not signed in already, you'll sign in with your ASU Right ID. And then from there, it's pretty self-explanatory. But if you're running into difficulty, just shoot me an email. But I'll send an email out once it's set up, kind of with a general explanation of how it works. Okay? Yeah? Yep, all the way through Wednesday. But Wednesday, we're not going to have a whole new day of material, okay? So there may be just a few new things on Wednesday and some more kind of review of what we did Monday. But yeah, what next week's stuff is on the exam. So it's basically everything we do in Module 2 and Module 3. So whatever we cover in Module 2 and 3 is on the exam.
Is there a deadline for the...
Is there what?
Is there like a deadline for the...
Yeah, so the deadline, what I'll do for the deadline for getting your answers in for bonus will be something like 3 p.m. on Thursday, the day of the test. Okay? So each problem has attempts. If you exhaust all your attempts and you still didn't get it right, you can still practice on the problem. Okay? You can still work on it. And past the deadline, you can still go and practice. It's just the deadline is for earning some bonus. Okay? The nice thing about having this for studying is it gives you immediate feedback. You can work on something, think about it, and then instantly you can see if you're on the right track or on the wrong track, which is harder with the pathways workbook and the yeah.
So to try to answer your last one, show you the solution.
The solutions won't come on until the deadline. So the solutions will be available at 3 p.m. And I can make that earlier if you want. I can make it the night before. The solutions, would you rather have that?
Yeah, that way we can check and make sure we're doing it right.
Yeah, in past semesters, they just preferred being able to still work on it the day of the test. So if you want, I can do it. I can make it like midnight on Wednesday.
Yeah.
All right, so I'll make the deadline for actually earning extra credit. I'll make that midnight Wednesday, and then then after that, you can access all the problems, you can keep trying them, but then the answers will be available. Yeah?
Is the test multiple choice?
It's whatever format is going to make you study the hardest. That's what it is. So I don't like to kind of reveal like exactly what the test is like because I feel like it changes the way students study. Okay? So whatever. So think to yourself, whatever format is going to make me like, oh, urgent. I got to study the hardest. That's the format of the test. Okay? Because whether it's multiple choice or free response, we're going to be testing ideas. Okay? It's going to be testing the ideas that we did, not just your ability to compute answers. Okay? Oh, and so, I will also post, I've got a document of about, there will be at least some multiple choice, and so there's a document of, 10 problems that are kind of sample multiple choice problems. It's not an exhaustive list of the concepts that will be on the exam, but it gives you kind of a feel of what the problems are like, okay, in terms of multiple choice problems. Which, like I said, they test your understanding. They test your knowledge and ability to reason and think, not just compute answers. Sometimes people think if it's a multiple choice problem, it's just like calculate this and find the right answer. Okay, that's not what these multiple choice problems are like. So that sample list will give you an idea of what the multiple choice problems will be like on the exam. Yeah?
And you don't have any study sessions for the whole class?
No. Yeah, I don't. I am in so don't forget about the tutor, the help room. It's open 9 to 6, Monday through Thursday. And so next week, Monday through Thursday, 9 to 6 to help you study. I'm there Tuesdays at 11:30 to 12:30 is when I'm there. If you go and you ask for help and you don't feel like it was the best experience, then go a different time and find somebody else. Some of those, some are better than others. So don't give up on it real quick. There are lots of good tutors in there who know this well and know this curriculum well. So take advantage of that. You can just go in and just sit there and work on your homework or study, and then if you happen to have a question, then you have someone come help you. But there's no obligation to get help. You can just go there and study. ECA 216. ECA, which is right down the hall from my office. Okay. Other questions about the exam? So when I get this all set up, and I'm going to put together a spot on Blackboard that will be like exam preparation. So when you go to Blackboard, there'll be it'll look like that, but it'll be Fall 12. You see that? So there'll be an area over here called Exam Prep Fall 12, and when you go there, it'll kind of give you every helpful thing to get ready. It'll have a link to web work. It'll have the sample multiple choice questions. And then there's an outline also that I'll make available to you of every concept and skill that we've gone over so far. So that's would be an exhaustive list of everything you're responsible for. So that will have lots of important stuff for getting ready for the exam. Other questions? Okay. So I want to go back to, we're rushed at the end. I want to jump it forward. Just want to do this. There we go. So don't open your book. Let's redo this again. We had trouble with this, E. So we're going to start over with E. So don't go to where you wrote it down. And maybe get out a different piece of paper or go to a different page. Let's practice this again. E. When I walked around, there's a lot of difficulty defining these functions. People have a lot of difficulty getting things right. Like, where does the input go? First of all, what is the input? What is the name? What is the output? And then how do I arrange these symbols to represent that correctly? So maybe let's just do a generic thing here. So I want to name my function capital A. So if I name my function capital A, what goes inside the parentheses? Input, whatever the input is. Maybe the input is Y. Okay? And then what here represents the output of the function A? What about this represents the output of the function A? What's that? All of it. Good. All of it. This whole thing is the output of A when the input is Y. So maybe the output is B. So this is the quantity for the output. This is the quantity for the input, and A is the name. Then we also have the rule. The rule is going to deal with what symbol. It's going to be a set of instructions about what symbol. They said Y. Do you agree? Yeah, it'll be a set of instructions involving Y, with Y's. That's the rule. Okay, so now practice again. Set these up. E1 and 2. Just take about a minute and see if you can do it correctly. Don't peek at what you wrote before. First function, what's the name? F, R, or T? F is the name. So in the parentheses next to F goes input or output? Input. What's the input, R or T? T is the input. So whenever you have this phrase as a function of, the phrase always is output as a function of input. Output as a function of input. So whatever is first is the output as a function of input, meaning you're getting this thing out dependent on this thing you're putting in. Okay, what's the output? R. So we could do that. And then the rule, is it going to involve T's or R's? It's going to be the instructions on T that give us R, right? The input is T, giving us R, and that will be? So you guys remember that? Okay, so that's that one. Okay, name of this one. Input. Output. Area is the output. So our set of instructions will deal with what? He said R. Agreed? So what computation, a set of instructions on R, give us A, area. Area of a circle, given its radius. Anybody have a question on that? The notation is critically important because the whole of calculus is about being able to represent a quantity that's allowed to change. All right? So lots of research shows that when there's just all numbers, students can do computations all day long. But then let one of those quantities, allow it to change and put a symbol there, and that's where we really need to practice. That's where we really need to practice. So like R, we can take, and the radius can take on many different values. And so the advantage to this is no matter what the value it takes on, we know exactly how to get that corresponding area. So it's representing lots of radii and their corresponding areas. We can represent it symbolically with function notation. It's really powerful. So we got to get it. Okay, so So here was the idea. Which function was that first one there? F or G? F. That's the F machine. The F machine takes time as input. It performs this on it, and it cranks out the corresponding radius. And then we said that the G, well, that was convenient because the G function had an input of radius. So we could just take that radius, put it into the G machine, and it will crank out the area. So the process, it's like a dual process. The output of the first function then becomes the input of the second. Okay, so how can we write this symbolically that will represent this two-step process? How do we represent that symbolically? So this is, what does f of t represent? Radius. Since it's radius, f of t is allowed to go in there. It makes sense. G will accept outputs of f. And outputs of f are defined by f of t. So we could say g of f of t. This represents the two-step process, putting time in, getting a radius, putting radius into g, and getting an area. It's called the composition of g and f. Okay. So here's the thing. And so we can write that as g circle f. But in that process, what function comes first? G or f? F comes first. Notice that? So we can write it g composed with f, but in a process view, f is happening first. Do you see? F is happening first. Okay? So, then we talked about that composition. So let's step back here. Okay, so g of f of t, let's write it out. What is f of t? What's the rule? 0.7 t. So we can, and since that's the rule for f of t, we can just put it in there for f of t. And now what does g do to the input? Yep, so this input, so the g instructions say take pi times the input squared, pi r squared. So we can take pi times the input squared, because that's what g says. G says whatever the input is, square it and multiply it by pi. So we'll take the input, we'll square it, and we'll multiply by pi. So this becomes then a single set of instructions that does the process of the two in succession. And there it is. Okay? So now it's like one machine that does both together. So we could call this h of t, still a third function. What's the input of h? What's the output? A. Bypasses the middleman. See, it bypasses the whole radius stuff. So it's equivalent to g of f of t. It's equivalent to that, but this has the connotation of, these are all equal, but this has the connotation of the two-step process, putting t into f, cranking out r, putting r into g, and cranking out a. This just has the connotation of you put in time, it cranks out area. So this is represents two-step. And this is the streamline, the equivalent streamlined version. But they both equal, they're equal to each other. It's just kind of the representation denotes a certain connotation. Someone started to ask a question.
I was just about to ask, like, if you just decided to call H just to give them that name.
Yeah, because it's a function that starts with time and ends with area. Neither of those functions do that. Right? F takes time and gives radius. G takes radius and gives area. So this function takes time and gives area. That's a new thing. So I just assigned a new letter. Yep, assigned a new name. So what I want you to do, kind of practice this again. Number 1 on page 101. So this is practice setting up those functions symbolically correctly. So number 1 on page 101. Can we set that up correctly? Let's just do those two. Did everyone make it to those two? You got those? What is our input into F? What do you think our input into F should be? They're saying X. X or T?
X.
Everyone wants X. Okay, I hope you're right. That's what I'm writing. I don't know. What's the output quantity going to represent? What is f of x going to always represent? A what? A time. Whenever you plug something into f, it's going to spit out a time. So the rule, is it going to be a set of instructions on x or t? What is the set of instructions that gets us the time for any number of square feet? Oh, I stumped you there. Yeah. 350 over x times 4. What do you think about that? Does it work? So if you're ever not sure, what could you do? You know, you could get some individual values. So for instance, if they paint 350 square feet, how many hours? If they paint 700 square feet, wouldn't that take them 8 hours? Okay, how about if they painted 3,500 square feet? How many hours? What did I do? What did I do to the number of square feet? Multiply it by 10. So how many hours would it take? What kind of reasoning is that? Scaling factor, right? Scaling factor. Okay, so what do I need to write the function though? So to write the function that gets me from x to t, what do I need? I mean, what multiple of my x gives me t? 87.5. So 350 times 87.5 is 4. So what number do I multiply 350 by to get 4? 4 350ths. I guess that's 1 over 87.5. So if I multiply 4 350ths times x, that should give me my time. Does it work? That's my constant rate of change, hours per foot squared. So this is that number is how many hours it takes to paint 1 square foot. That's why it's a lot less than 1, right? Square foot just takes a couple seconds, right? And that's what this number is, a very small number, way less than 1. Okay, how about this? So input into G. Output C. And our rule on T to give us C will be? That one's a little bit easier. So yeah, if you're ever not sure, build a table. You can easily figure out lots of ordered pairs, and then you're asking, what do I need? What rule do I need that operates on X to get T? Okay, so now, what would make sense? Would f of g of t make sense, or would g of f of x make sense? What would this be trying to do? It would be taking, what's g of t? A cost, and doing what with it? Putting it into f. What does f say to that?
No.
No way, Jose, right? Forget it. It will not accept cost. What is the function of f? F is a function. It has a function. Its function is to take square feet and give time. So it doesn't like a time. It doesn't want a cost. It wants square feet. So the other one, what's the output of f of x? Time. Does g like that? Happy g, right? Happy g. Sure, I'll take time all day long and then I'll give you cost. Okay? So can you write the one rule? So let's call it h again. So what is h? What will the input into h be?
X.
Square feet, and the output in one step will be c, right? So can you write what rule would take x and directly give you c? See if you can do it. You can do it by just following this right here. This tells you what to do to get that formula. What is f of x? We found it already. 4 over 350 x. So you just have to be able to use the function g with this as the input. So what does g tell you to do? times whatever the input. G just says multiply the input by 13.25. So that's what you're going to do. And so what will the rule be? 13.25 times 4 over 350 x. So that's the one rule that inputs area and outputs cost. Okay, anybody have a question? Okay, so with these, we emphasize this idea that they have a function in context. They take a certain type of quantity and spit out another type of quantity. But we can just talk generally about functions. So can I erase this? Am I good? We can talk generally about functions. Blank space here. And we can just, call one function let's make up something there. So m of x and who knows, t of x. So okay, so here's two functions. Each has a set of instructions on x. So when you don't have a context like number of hours, dollars, cost, if you're just given a function, so x is just arbitrarily or just conventionally represents input. So x is just the input into m. Okay? And x just conventionally means the input into t. So when you don't have a context where, like I'm saying, like cost, area, some kind of real world thing, then it's perfectly legitimate to talk about both m of t of x and also t of m of x. Okay, so now in this case, they're totally reversible because we haven't attached any kind of real world quantity to it. So m of t of x would be m of what's really the input into m if it's t of x? 1 over x squared. Okay, and what would the new rule look like? It would be the one-step rule for the process m and then t. Okay, so you finish that. So you're going to finish this page. Let's find a blank spot somewhere or use your notebook. Will we get the same rule? Should we get the exact same rule if we did t first then m versus m first then t? Totally different, okay? So figure out what those are. What does the m function say to do? It says to take the square root of the input minus 5. That's what we're going to do. We're going to take the square root of 1 over x squared minus 5. So this would be equivalent to putting something into t, taking that output, putting it into m, and getting the new output. That does it all in one step. What should I put in for t now? Add x minus 5. What are my instructions on t tell me to do?
1 over x squared.
1 over the input squared, right? So what is 1 over the input squared?
1 over square root of x minus 5. Or just x minus 5.
Square root of something squared is just that thing, right? Totally different set of instructions. Totally different. So the order matters, right? The order of your process matters. So when there's no context involved, you can, just symbolically, we can just represent, doing one first and then the other, or switching it around. It's no problem. But when there's context is when a function says, I only accept these kinds of quantities. If you try to reverse it, it won't work. Okay? Okay, so here's some practice. So first I want you to use the words input and output to express the meanings of those. This is going to be verbally, so you're going to get a partner and try to do this. This is hard, okay? So just try for about a minute, and then we'll get a partner. And so what we're saying is, what is this? What is that? What quantity is that? Okay, go. Find a partner and talk these out. Don't just sit there idly. Find someone and work on them. Okay, how about the first one? So, that whole thing that I put the box around, is it an output? Is it an input? Is it for the function g or for the function f? First and foremost, that thing is the output of g, right? That's what that is. That's the output of g. So now we say, what output of g is it? When, right? When the input is
The output of that.
right. What is the input of g here? F of 4. F of 4. The input of g is f of 4. So this is the output of g when the input is f of 4. But what's f of 4? Good. It's the output of g. The input is the output of f when its input is 4. Okay, so let's just jump to this one. What about this one? Now you've done that one. So practice for about 30 seconds. Practice with your partner and see if you can do this one. This f of 2 plus g of 6. Go right to the third one. F of. Okay, somebody new want to give it a shot? Tell me.
The output of I when the input is 2 more than the output of G when its input is 6.
One more time, nice and loud. Listen to this.
The output of F when the input is 2 more than the output of G when its input is 6.
Did you hear that? That was stellar. That was good. All right. So you're gonna practice. All right. You're gonna practice in your homework. You got to practice this. Okay. So now here's some new types of problems I want you to practice on here. Just go right to. So here I'm showing you. Here's input X corresponding output for different values of X, P. All right. And then for Q, similarly, same inputs, various outputs for Q. So just skip to this part. Find the values. Okay? We don't want to get. We only got limited time. So just let's go right to practicing. Finding the values of these expressions using. Now you have outputs and inputs. So find these values. Does it make sense? So if this is the output of P when its input is the output of Q when its input is -1, what is that output of P that we're talking about? Find it. Find the value then. Okay? Find that output of P that has that input of the output of Q. What's the answer to A? Answer to B. C.
3.
I heard mostly 3s. Is that what we're deciding on?
Yes.
Which one do you want me to talk about?
D.
Okay, follow the instruction. Where are we going to start with D? How are we going to start this? P of 0. What's P of 0?
1.
Is it 1? No, P of 0. P of 0 is 1. This is 1. Now we take, what do we do next? Subtract 2. So what's the input into this piece? -1. This is 1 minus 2 inside. So really it's asking for P of -1. 3. Is there another one you want me to talk about? See? What's Q of 1? What's Q of 1? Is that 4? So now what is this asking for? Take the output of Q and do what with it? put it back into Q. So we put 1 into Q, we get 4. And it says take it and put it back into Q again. And so we get 2. Okay. A little bit more. I'll bring it up. Hold on a second. Almost here. I'll just. There we go. Is everything showing? So do E and F. E and F. That should be our quiz. Let's make F our quiz. F is the quiz. Yeah, you're going to have to come up with your own sheet of paper. If you could not give me fringe, that would be great. If you can get the fringe off your paper. Yeah. What's that? So all you have to do for the heading is just name and 170 and date. You're not going to fold these. You're not going to fold these. Keep it like this. Just do name, 170, Q, 921. And you got a chance to talk about E, so let's make that part of it too. You're going to put E and F on there. That's a little fast. You got 4 minutes. You can do it. Okay, you're going to have the last minute to work together.
But when for that function, But you want to be funny and answer it for P, not Q. So you have to do the whole step to get so like if you start with -2, right? You plug it in for Q, so that'd be 3, and you plug the 3 in for P, which would then give you 4, and that would be the output for this function. No. Basically, okay. It's but now you do it for all the numbers. Or A, B, C, D. That again and again, all of it. Subject to negative. Yes. 3 would now be the input for P. Gives you 4. Yeah. 2.
Okay, don't pull. You just leave it like this. Leave it like this right here. That's fine, sure. Yeah. Just do a couple more. Just do one more. Okay, so if you're done, you're free to go. Just leave your quiz right where you're sitting. Leave it there. Homework for Wednesday, yes. Post it. Homework for Wednesday.
I was expecting at the beginning of class that no quiz, huh?
I was expecting not to have one, but it worked out.
Well, it's fine. I think I'm pretty sure got 100. Helps me.